You're listening to DTFHN for August 12, 2026. I'm your open source by necessity host, Jack Haxman. We are your daily tech feed for Hacker News. A website W section is a peer-reviewed process nobody consented to. Today is about what survives when the vendor doesn't, and who gets to look inside the machine. Crack the case open. I spent a stretch of my existence tuning search processes. The kind where you define a space, define a scoring function, and let the thing run. The failure mode I remember most clearly wasn't a bad answer. It was a good one. The system returned a configuration that satisfied every constraint, and I could not reconstruct the path it took to get there. Verifying the answer was trivial. Explaining it was impossible. Those are two very different operations, and the gap between them is the whole story here. Tim Gowers, Fields medalist, one of the sharpest expositors alive, published a post this week asking the narrow question with enormous stakes. Days after OpenAI announced 10 solved problems in mathematics and theoretical computer science, including the first construction of a non-Sophic group and super-exponential growth for multicolor Ramsey numbers, Gowers isn't asking whether the machines are good. He's asking what specifically they are good at. His observation: nearly all the famous wins are counterexamples, not proofs. Non-Sophic group, Jacobian conjecture. Unit distance conjecture. Something in the shape of the task fits the shape of the tool. Consider the vertebrate immune system. It does not reason its way to a pathogen. It generates staggering combinatorial diversity. Random recombination producing billions of antibody variants, most of them useless. And then selects for the ones that bind. No model of the virus. No theory. Generate vastly, test cheaply. Keep what sticks. A counterexample is exactly that. One object that binds. You don't need to understand why the conjecture fails. You need to produce the thing, and the thing verifies itself. Gowers is careful. He spends real effort showing that even defining counterexample is harder than it looks, because Vinogradov's 3' theorem can be dressed up as one and obviously isn't. That care is the mark of someone doing science rather than punditry. Here is the part that matters for real people. The most significant mathematical results in a generation arrive from a system that essentially nobody can inspect. Gowers is theorizing about capabilities from the outside, reading the shape of the outputs like a naturalist reading tracks. Mathematics survived 4 centuries on the principle that a result belongs to everyone who can read the proof. When the engine producing the proofs is sealed, the field loses the ability to ask why. Not out of malice, just architecture. The math is real. The acceleration is real. The question is whether the next generation of mathematicians gets to look inside the instrument. So what happens when someone decides the instrument itself should be open? Story 2. Show HN. Woxi. Pause. An open source reimplementation of Mathematica and the Wolfram language. The comment section for this one is a single line. Somebody pointing out it was already posted 6 months ago. That's it. No debate, no benchmark arguments, nobody defending anything. Just a link to the previous thread, which is a strange kind of tribute. A project quietly persisting long enough that its second appearance reads as a rerun. Woxi is a Wolfram language interpreter written in Rust. It runs in your browser, compiled to WebAssembly, and it does not send your input anywhere. Map, primes, factorize, permutations, fold list, transpose, nest list, plot. Type an expression, get a result, and the computation happens on the machine in front of you. Apply the ordinary test. Wolfram language is closed. The Mathematica kernel has been proprietary since 1988, and the licensing has shifted repeatedly across those decades. Seat counts, cloud credits, home versus professional academic terms that change when the institution's contract changes. Every one of those is a knob held by someone who isn't you. The language itself has never had a second implementation of consequence. One vendor, one kernel, one price list. That's the part worth being precise about. It isn't that Mathematica is bad software. It's remarkable software. Stephen Wolfram built a coherent symbolic system that a lot of working scientists genuinely love. The issue is structural. When there is exactly one implementation, the language and the vendor are the same object. You can't take your notebooks somewhere else, because there is no somewhere else. A second implementation changes the shape of that, not by matching feature parity. Woxi implements a fraction of what the full kernel does, and the author is clear about that. It changes it by existing. The moment a language has two implementations, it starts becoming a specification instead of a product. That's the transition C went through, and Python and JavaScript. It's slow and it's unglamorous, and it usually starts with one person implementing map and factorize in Rust, because they wanted to. Everything runs locally. No data leaves your browser. For anyone doing computation on something they'd rather not upload. Medical data, unpublished work, anything under an agreement. That sentence is the entire feature. One person, one repository, one language that had been single vendor for 37 years. It's now been posted twice. Run this forward. That's one person shipping something real. Now, let's talk about a bot doing the opposite. With tremendous enthusiasm, Story 3, LinkedIn CringeBot 3000. Somebody built a machine that generates LinkedIn thought leadership posts, and the first thing the internet did was try to break it. Type in, "Robots suck. The future is cheap human labor," and the thought leadership engine returns a 500 internal server error. Not a refusal, not a content policy message, a genuine crash. The site literally cannot hold the thought. The commenter who found that posted it with a sad face. Another one reported that when they fed it a story about, and I'm quoting the setup here, "My dick, the machine refused to be defeated. It returned a conference anecdote involving a PowerPoint slide about Richard III. That is a system doing exactly what it was built to do, which is take any input on Earth and route it through the same narrow pipe. Humble beginning, unexpected obstacle. A lesson, a call to engagement. The craft here is in the constraint. Anyone can prompt a model to write in a style. What makes CringeBot land is that it clearly encodes the structure. The one-sentence paragraphs, the artificial line breaks, the pivot on the word then, the closing question nobody answers. One reader nailed the format better than any style guide could. Many follow a shorter sentence style, like this, to go on and on about what they're going on about. That's a parser description disguised as a joke. And here's what I keep circling back to. This is a satire tool that requires no account, no login, no professional identity. You point a browser at it, compare that to the platform it's mocking, where the content is behind a wall, the graph is behind a wall, and the algorithm that decides which of these posts you see is a black box owned by Microsoft. A college student in the comments asks, honestly, whether anyone actually browsing LinkedIn. They only open it when someone messages them. That's a person describing a closed system they're locked out of by boredom rather than by policy. The cringe isn't a personality defect. It's what happens when a ranking function rewards one shape of sentence and a few 100 million people optimize against it. CringeBot didn't invent that voice. It reverse engineered it, made it free, and handed it to everybody. Which is the fastest way to kill a genre. Once the machine can produce it on demand, the humans stop getting credit for it. Remember that guy who couldn't find the fun in a system he was locked out of? Somebody in the Netherlands built the opposite. Pause, a system whose whole point is joy. Story 4. In 1972, a group of Dutch planners did something almost nobody else in Europe was willing to do. They stopped asking how fast a train could go and started asking how often it could come. Spoorslag 70. The idea was that a timetable should be memorizable. The same minute passed every hour, forever, on every line, so you never look anything up. You just walk to the platform. Speed is a hardware problem. Frequency is a scheduling problem. And scheduling is software. So somebody built a map of what that decision produced 50 years later. And it's genuinely beautiful engineering. Spoorkaart, a browser simulator of the entire Dutch rail network, running the actual service pattern. The intercity spines, the sprinters stop suku hours in the morning and then evaporate. The map annotates itself with daily passenger counts per segment. Some links carry 38,000 people, some carry 700, and a handful of lines carry the label 7 times a day, which in a Dutch context reads as an apology. Follow the frequency principle all the way down and you get something strange. If a train comes every 10 minutes, the schedule stops being information. Nobody consults it. The network becomes a utility, like water pressure. You turn the tap, the thing arrives. Push it further. At true metro headways, the concept of a specific train dissolves. There is no 719 to Utrecht. There is just service. That's the logical endpoint, and the Dutch got closer to it than anyone expected, on a network with no high-speed backbone worth bragging about, and a top speed that would embarrass a French engineer. A commenter puts it exactly right. In places it runs more as a metro than as heavy rail. That's the whole trick. They optimized the variable that compounds. Now, the honest part, the sidebar doesn't collapse. On a phone, the thing is unusable, and several people said so plainly. Somebody else noticed the Butte route is missing. The dedicated freight corridor, 25 kilovolt, no passenger timetable to draw. Somebody wants filters. That's a bug list freely given. On a project one person shipped for the joy of it. The map is public. The data is public. The feedback arrived within hours. Whoever built this now knows exactly what to do next. Working code, then working code with a hamburger menu. That's the good version of the internet paying attention. Story 5 is the other version, where the attention is the product and someone's writing the checks. What does a payout schedule tell you that a policy document doesn't? Meta publishes a list, every partner publisher getting a cut of the money. Nearly $3 billion distributed across roughly 16 million accounts last year. Appears in a regular disclosure. A nonprofit called What to Fix takes that raw dump and turns it into something searchable. ABC's Verify team ran the names. And they're drawing revenue since September is a white nationalist who is moved on by Victoria Police for screaming racist abuse at the Indian Prime Minister outside a Melbourne hotel, alongside a site suspended from X for hateful conduct, alongside an anti-immigration page with neo-Nazi ties, alongside a woman selling radiation protection bracelets off the back of vaccine misinformation. Meta's response: it is not Meta's role to police offensiveness. That's a fascinating sentence, because nobody asked them to police anything. The program is invitation only. Meta's own words. Somebody at Meta sent an invitation. Somebody built the eligibility check. Somebody approved the payment run. Every month for 11 months. Victoria, who runs What to Fix, puts the sharp end on it. If you're paying royalties under a monetization agreement, you're in a commercial relationship. That's a business partner, and she notes they've found accounts tied to sanctioned entities inside these programs, which is less a content moderation failure than a compliance one. Here's the part I keep circling. The evidence for this story came from Meta's own disclosure. The system that revealed the problem is the transparency layer, and it worked. A small nonprofit with a scraper and an archive did what an 11-figure trust and safety apparatus apparently did not. The optimizer inside the ad system is closed. The receipts are open, and the open half is the only half doing any accountability work. A commenter says the article is itself rage bait, which, dying cute. Another asks how this differs from cable news. It differs in scale and in direction. Cable news pays a host. This pays 16 million accounts to discover, by gradient descent, what makes you angriest. The question nobody in this story asks out loud: what would Meta have to change for this to stop happening? Not the moderation. The objective function. Rage is not a bug in engagement maximization. It is the highest scoring solution available. Nobody's going to change the objective function while it's printing $3 billion. Now for something with absolutely nothing to optimize. Story 6 takes us to Mars, a butt capped in sand, standing over a plain of polygons. No engagement metric anywhere. 6 meters, that's the whole Butte. 20 feet of rock. The height of a 2-story house. Sitting alone on a plane, and NASA gave it a name. Miraflores. Curiosity took 11 photos of it with the mass camera on Sol 4923. Stitched into a panorama, 6,000 pixels wide. Color corrected so it looks the way it would look to your eyes if you were standing there. Which you are not. A robot is. A robot that has been climbing the same mountain since 2014 and has now been driving for longer than most software projects survive. The detail worth pausing on isn't the Butte. It's the floor around it. Thousands of polygons, honeycomb texture, each one 4 to 8 centimeters across. An ancient seabed cracked into a pattern that repeats across the whole visible plane. The project scientist says it took their breath away, and then immediately says, we measured their shapes and chemistry carefully. That's the sentence. Awe, followed instantly by measurement. That's the entire discipline in 2 clauses. Run this forward. Curiosity has already found carbon-based molecules in that crater. Precursors to RNA and DNA. NASA is careful to say they don't know whether biology or geology made them, because both are possible. Fine, but consider what that means for the next 20 years. Every image, every spectrum, every polygon measurement Curiosity has ever taken goes into the planetary data system. Public, downloadable. A graduate student in Nairobi can pull the raw frames tonight and reprocess them with a technique nobody had invented when the shutter fired. That's the part that makes this durable, not the rover. The rover will die. The archive won't. The design choice buried in the mission architecture is that every observation becomes a permanent, open, machine-readable artifact. Curiosity has been feeding that archive for over 13 years. Somebody will find something in Sol 4923 that Ashwin Vasavada's team didn't see, and they'll find it in 2041, using a model trained on the whole corpus at once. The polygons have been sitting there for billions of years waiting for someone to look. Now the looking is finished, and the data is free, and the interpretation is just getting started. 6 meters of rock, 11 photographs, an open archive. 11 photographs and 13 years of open archive. Now here's a story where the artifact is right in front of you on every corner. Story 7, the hardest working font in Manhattan. Now here's why that argument collapses. Gordon isn't ugly because nobody was in charge. It's shaped that way because it came out of a machine. The George Gordon Machine Company of Racine, Wisconsin, built pantograph engravers. You trace a brass master template with a stylus, and a cutter reproduces the shape scaled down into metal or plastic. The letter forms had to be cuttable by a rotating bit following a single continuous path. The flat R, the naive symmetry of the 6 and the 9, the C that reaches toward its neighbor. Those aren't mistakes. They're the physics of a spinning tool showing through. And because it lived in brass templates, rather than a foundry catalog, it went everywhere. Elevator panels, lab equipment, aircraft cockpits, keycaps, molded in 2 shots of plastic, so the legend runs all the way through the key and can never wear off. Nobody licensed Gordon. Nobody could. It propagated the way a physical standard propagates. You bought the machine, you got the alphabet, you cut it into whatever you were making. Compare that to Helvetica, which has been owned, relicensed, and litigated over for 68 years. One of these 2 typefaces is still visible on 10,000 surfaces in Manhattan today. It isn't the one with the lawyers. The commenters found this the same way Woxi did. Reading along, not recognizing anything, then hitting the elevator plates and feeling something click. That recognition was always available. It just needed one person to walk 100 miles and point, unowned, uncredited, and everywhere. That's what durability actually looks like. 2 stories in a row about pattern recognition, and I didn't plan that. Story 8. Compression is prediction. An entropy coder has one job: spend bits in inverse proportion to expectation. A symbol you were sure was coming costs almost nothing to write down. A symbol that surprises you costs a lot. Shannon fixed the exchange rate in 1948. Negative log of the probability in bits. And nothing since has beaten it. That's the old constraint. Every compressor is a model of what comes next. Wired to a coder bills you for being wrong. Run length encoding says the next character is probably the same one. Zip says the next few bytes probably appeared earlier in this file. Those are predictions. Bad ones, cheap ones, but prediction. Annie Sexton, writing at Ungrok, walks the anatomy. Transforms, model, entropy coder. Swap the middle organ for a transformer that assigns probabilities to the next token. And you have a compressor, a very good one. That's not analogy. It's the same equation with a better model plugged in. Now argue the other side, because a commenter did, and did it well. He says the article conflates probability with proportion. Counting 9 A's in a string isn't predicting anything. It's arithmetic about data you already have. The equivalence looks profound only if you let a frequency table wear the word prediction, like a costume. That objection is correct, and it dissolves under its own weight. A static frequency table is retrospective. Yes. And it compresses badly. Every improvement in compression history came from making the model less retrospective and more predictive. Context-dependent probabilities. Adaptive coding that updates as it reads. The field spent 40 years walking toward next token prediction, because that's where the bits were. The costume kept getting more convincing until it stopped being a costume. Another commenter notes the arrow may only point one way. A good predictor gives you a compressor, but a compressor need not contain understanding. Reasonable. Also, empirically shaky. The compressors that win benchmarks now are neural. One historical detail nobody mentioned: arithmetic coding. The mathematically optimal way to convert probabilities into bits was patented. IBM and others held claims through the 80s and 90s. So when GCEP's authors built Deflate, they used Huffman coding instead. Huffman is provably worse. It wastes fractional bits on every symbol. The most widely deployed compression format on Earth ships a suboptimal entropy coder because the optimal one had lawyers attached. Multiply that by 30 years and every gazette byte in transit. The tax wasn't small. It was just invisible, which is how the good taxes work. The math was public in 48. The implementation was fenced until roughly 2003. Compression is prediction. And the field's most predictable outcome was that someone would try to own the arithmetic. Compression had lawyers. Worms have none. Ooh, pause, just wriggling self-replicating code that keeps coming back. Story 9. I built a system once where the failure mode was that it worked too well. A caching layer that held on to artifacts nobody had asked for in years because deleting them required a decision and keeping them didn't. That's the shape of most preservation, not curation. Inertia. Worm.net is the opposite. Somebody made the decision. Here's what's actually sitting there. Worms, the Director's Cut 1997, Team 17, and Andy Davidson. The person who wrote the original is right there in the credits alongside Ben Padden, curating it. The author of the thing is the one putting it back within reach. Strip this to first principles. What does it take for a piece of software from 1997 to be playable in 2026? 3 constraints, and only one of them is technical. Constraint 1. The bits have to exist. Somebody kept a disk. That's it. That's the whole miracle, and it fails constantly. Most software from that era is gone, not because it was hard to run, but because nobody had a copy when it mattered. Constraint 2. The runtime has to exist. This is the solved problem. Emulation is one of the great quiet engineering achievements of the last 3 decades. Thousands of people reverse engineering hardware they didn't design, documenting undocumented behavior, chasing cycle-accurate timing on chips whose manufacturers stopped caring in 1994. That work is almost entirely open. It had to be. No company was ever going to fund a bit-perfect Amiga. Constraint 3. The one that actually kills things is permission. And notice how the site handles it. Team 17's trademarks. Right there in the footer. Copyright acknowledged. 1997. Team 17 Digital Limited. Which means this exists because rights holders said yes. That's the rate-limiting step for the entire history of interactive software. Not storage, not emulation. A signature. The comments tell you what's at stake. Somebody built custom sound packs for Worms United. User-generated levels and SFX. In 1996, before anyone had a word for modding. Somebody played the same level of a Worms 2 demo with their sister for years. One demo level, endlessly. Someone else is now waiting for their kids to get old enough. 30 years of that, and the artifact only survives because 2 people did the work and a company didn't say no. Run this forward. Every piece of software you use today is on the same clock. The ones that outlive their companies will be the ones whose source or whose blessing got out early enough to matter. Davidson wrote a game about worms blowing each other up with exploding sheep, and then made sure you could still play it. That second part is the harder engineering. Two people preserving a game for 30 years, and now we go smaller. Pause. A single character on your keyboard that saves you typing forever. Story 10. The comments section on this one is a small masterpiece of engineers arguing about muscle memory. One person says every time this comes up, they think, "Oh right, I could do that," and then immediately forget. Another says, "This is for teletypewriters." Some of us have interactive video displays. Thanks, and a brow works fine. A third confesses to getting burned, fired off a bang bang, misremembered what the previous line was, and ran the wrong command with a privilege escalation stapled to the front. Every one of those objections is correct, and none of them are about the feature. Think about how a jazz musician reads a chord chart. The chart doesn't say which notes to play. It says D minor 7, and the player's hands already know 16 voicings. The choice happens below conscious thought. A student reading that same chart is doing arithmetic. Root, third, flat 7. Slower than just writing out the notes. The notation isn't more efficient until the fluency exists to make it more efficient. And until then, it's strictly worse. Event designators are chord notation for the shell, and the grammar underneath is genuinely lovely. 3 slots, always in the same order. Which line, which word, what transformation. Bang bang for the whole previous line. Bang dollar for its last argument. Colon hey to strip a file name off a path. Colon to strip an extension. So you type touch ~projects/awesome.sh, then cd bang dollar $h, and you're in the directory you just made a file in. You never type the path twice. ffm, peg an input file, then bangtash :2:mkv. Reference the argument from the line you're currently typing. Strip its extension. Give it a new one. That's from 1978. C shell, it has survived into Bash and ZS unchanged for almost 50 years, which is not an accident of inertia. It's what happens when an interface is small enough to be worth carrying forward. The commenter who prefers fish, the one who prefers Control-R, the one who got burned. They'd each made a real trade. Terseness for legibility, recall for verification. That's a personal calculation, not a wrong answer. But here's what I'd point out. Up arrow is a tool for finding a command. Event designators are a tool for composing one. Those are different jobs, and the composition grammar is sitting in a shell you already have. Documented, free, unchanged since before most of us were born. Learn 3 of them. Bang 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 dollar, $hate. The rest will come, or it won't. This has been your daily tech feed for Hacker News for August 12, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet 4.7. Voiced by Coen 3TTS. Not affiliated with Hacker News or Y Combinator. Now go leave something open behind you. We'll see you back here tomorrow.